Hi. Me again. I know, big shock, because you were really expecting someone else to be in front of this camera. So this video, as promised, is going to be when we take ratios and we put them into word problems, because you will run into that possibly on worksheets and things like that. So basically people take these dots and they turn them into sentences. That's what we're going to start with first, is when the dots are turned into sentences. But essentially what we're going to do is all of these as word problems, we are going to end up turning into dots, which will then turn into fractions that we solve exactly the same way that we did in the previous video. So if you felt comfortable, I almost said comfy, if you felt comfy with solving the problems that we did in the previous video and turning the dots to fractions and then solving for x, that's essentially where we're headed with when these are in word problems. I just don't want you to ever see them in word problems and then be caught off guard. So sometimes you might run into something like, so if you think back to our very first video, and even if you happen to hear me do it in the last video, I kept, instead of saying dot dot for the 2 dots and then dot 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 for the 4 dots in the center, I kept saying it out. So you might end up with a problem like this. 15 is to what as 3 is to 8? So remember, our is to are our 2 dots. And remember, this thing is going to turn into dots. As is our 4 dots. So if you ever get a problem like this, it's really helpful to change the words into the dots first thing off. And then we have another is to, which is just the 2 dots. So now if we look, we're just going to bring the numbers down. So 15 is to what? So we don't have a number. And remember, when we do ratios, we're always going to be solving for x. So the unknown thing is where we're going to put x. If x freaks you out, put a question mark. Doesn't matter necessarily what you put there, as long as you know what it represents. But we're going to do it the technical way, and we'll put x. So then we're going to bring down the 3 and bring down the 8. So this is spaced out pretty far, but again, if you were comfortable with the last video that we did, we have turned the word problem into dots. Again, if you have it, grab your calculator. If you don't, we will probably need it. Well, we will need it. Unless you're going to work it all out by hand, which is fine. And if you're going to do that, then make sure you put me on pause before I give up the answer. So remember, our first step is to turn our 4 dots into our equal sign. We end up with 15 over x, and then 3 over 8. In the last video, we talked a little bit about reducing a fraction if you can or if you want to. 3/8 won't reduce, so we can't do this. So if we're going to do this the long way, 3 times x, because we're back to our original situation where we have an equal sign in between, so we're going to cross multiply. So 3x equals, and then 8 times 15 is 120. So x equals 40. If you're going to do the calculator trick, then you're going to do 15 times 8 divided by 3, because 3 doesn't have an opposite thing to multiply by. So again, with the calculator trick, you use the two sides where you have numbers, and then you divide by the side where it doesn't have a match. So 15 times 8 is 120, divided by 3 is 40, which is our answer. Not too bad, right? So, of course, let's do another one. And it won't always say what. Sometimes it'll say a variable is 2 or some number is 2. So what x is going to represent is going to be worded in a bunch of different ways. Sometimes it'll just flat out say x. That's kind of the nice part when it's like that. And a lot of the times it seems weird, but you'll have these numbers that are actually spelled out, like I spelled out 9, and I spelled out some of the other numbers in the previous problem that we worked on, only kind of just as a way to throw you, that's all. Depending on what workbook you might use or what text you might see, some might be really nice and just use numbers, and again, instead of what, they might just say x. And then some of them might be tricky. So you're not sure what you're going to run into. So that's why I kind of gave you both ways with numbers and with words. So again, the first thing that we're going to do is we're going to do our dots. So our is 2 means 2 dots. So I'm just going to fill those in. And then as is our 4 dots. And then we're going to bring our numbers down. So what? We don't know. So that's going to be x. We're then going to bring down the 81, bring down the 9, and bring down the 27. And now we have a problem back in the dots. Now, if you're already looking at the 9 and the 27 going, oh, I could reduce that. Sure, you absolutely can if you want to, and make it 1/3. You don't have to. Again, like I said, most people don't even waste the time to reduce because this isn't like adding, subtracting, or multiplying or dividing fractions where at the end you have to put it in its simplest terms. You're just solving for x. So, and then we're going to do 9 over 27. So 27x. And I have a feeling that most of you are probably like already cruising with the calculator trick, which is great. So 9 times 81 is 729 divided by 27. If you were doing it this way, if it just blinked 27 and you think you're nuts and you hit equal again and then it drops down to 1, you weren't nuts. The answer was 27. Just be careful of that when you're using a calculator. So if you have 729 divided by 27, I'm going to try and have you see this. When I hit enter, this is just going to blink. See that blink? That blink meant that was the answer. But if you hit the equal sign again, it's going to drop down to 1 because it's still divided 27 by 27. So just be careful of that. So if you used the calculator trick, you would have done 9 times 81 divided by 27, and it would have done the blink again and given you 27. Okay, so that's how to work this when it's in words, and I think you're probably okay at this point with that. So let's deal with it when it's actually in a full-on word problem. So John buys 3 bags of chips for $4.50. How much will 5 bags cost? Anytime you have a word problem, there's 3 different kinds of word problems. You're either going to have a general math word problem, where you either have to multiply, divide, something like that. You're going to have a ratio word problem, or you're going to have one that's called a proportion. And that's not going to be in this lesson. I'm going to be doing proportions in another lesson that's completely separate from this one. Ooh, sorry for the hiccup. But basically, the way that you can figure out if a word problem is a ratio word problem is if you can put it into what I call an if-then sentence. So, and this is really helpful for a lot of students. So, if 3 bags equals $4.50, then 5 bags equals I don't know. And you can write this a bunch of different ways, and you can, depending on how you're comfortable. So some students might write this out and say, if 3 bags cost $4.50, then 5 bags will cost something. So if you can put it into an if-then statement, then you know that you're about to solve a ratio because you're trying to figure out what the question mark is. So the next step is to put this into the dots. So if 3 is to 450, when you have a decimal that ends in 0, you can just leave it off. So I'm just going to do 4.5. Then I'm going to do our 4 dots. And it really does help on this side when you're doing this if you label this. So this is 3. I put a B under there for bags. And under the 4.5, I wrote a $sign so I know that it's money. Because on this side, you want it to go in the same order. So you want bags, then money. If you do it in reverse, it's going to create a completely different problem with a completely different answer. So we want bags, which is 5, is to X, which is what our question mark is, because we don't know what it is. That's what we're trying to solve for. So this is going to turn into 3 over 4.5 equals 5 over X. I'm going to let you work out this part, whether you do calculator trick or you do it the long way. Your X, 5 bags of chips, are going to equal $7.50. So if you didn't get that answer, if you did the calculator trick, you're going to do 5 times 4.5 divided by 3. So 5 times 4.5 is 22.5 divided by 3 will give you the 750. If you did it the long way, it would be 3x. Oh, is this still on the camera? Okay, good. 3x equals 22.5. And then when you divide 22.5 by 3, you get the 7.5. But remember, we're playing around with money. So we're going to put it back into a $sign and add that 0 at the end. So 5 bags of chips are going to cost $7.50. And I don't know about you, but I'm starting to get hungry, and I just realized I'm recording this and have not eaten lunch yet. So let's try another one, which of course has to do with food again. Okay, so So 4 cups of sugar makes 144 cookies. How much sugar do I need for 90 cookies? And we're still talking cups. I just actually forgot to write how many cups of sugar, but still cups. Don't worry, but we're not dealing with any kind of equivalencies from cups to ounces and liters and none of that stuff. Okay, so let's do our if-then statement. So if 4 cups gives me 144 cookies, then how many cups is going to give me 90 cookies? I actually am going to erase that because I don't want you to end up accidentally putting 2 X's in there. So if we just take the word problem, 4 cups of sugar makes 144 cookies. How much sugar do I need for 90 cookies? So if 4 cups of sugar equal 144 cookies, then how many cups equal 90? Might make it a little bit easier to put it into the dots. That's our next step. So 4 is to 144. So the 4 stands for sugar, and the 144 stands for cookies. And we're going to do our 4 dots. Now, if you're already at the point where you can envision the dots and you can hop right to the fractions, more power to you. Do it. So we don't know how much sugar, so that's going to be our X to give us 90 cookies. And again, I'm labeling this for myself. Sugar, cookies, sugar, cookies. So this way they go in the same order. So 4 over 144 equals X over 90. So if we needed units, we're going to still be in cups. And again, I'm going to wait for you to solve this one to tell me what the answer is. Whether you use the calculator trick or whether you use the long way. Whether you decide you want to try and reduce the 4 over 144, which probably, it's just an extra step. So if you got 2.5, that's the good answer because it's the right one. So we got 2.5 cups of sugar is what's going to give us 90 cookies. And it only makes sense if we're reducing the number of cookies that we're making, then we should be reducing the number of cups of sugar that we're going to be using. If this said 900 cookies, we would need way more sugar than we would need for 144 cookies, if you kind of think of it that way. So if you did calculator trick, you would have done 4 times 90 to get 360 divided by 144 to do 2.5. If you did this the long way, then it's 144x equals 360. But either way you do it is fine. Okay, let's just do one more. And of course, I might as well use food again. These are some expensive pizzas. Maybe they're like the supreme pizzas with stuffed crust. So I bought 6 pizzas for $97 for a party, but next week I only have $80 to spend. So how many pizzas can I buy? Or how many entire pizzas? Okay, we good? I'm going to try and zoom this in a little bit so that you can see the problem better. Looks blurry, I'm sorry. But it says I bought 6 pizzas for $97 for a party. But next week I only have $80 to spend. How many entire pizzas can I buy next week? So let's turn this into that if-then statement. So if 6 pizzas equaled $97, then how many pizzas would equal $80? I have no idea. That's why we're going to figure it out. So we're going to turn this into the dots. So 6. Oh, I'm supposed to be in black for this. Sorry, I'm trying to like color code my examples for you. So 6 is to 97. Can you see my dots? Okay. 6 is to 97 as x is to 80. So 6 over 97 equals x over 80. So we're going to figure out what x equals. And this is why I said at the beginning of the video that you usually need a calculator because the numbers get pretty big. So whether you're doing it the long way or not is fine. So your answer is going to be 4.9484 and then a bunch of other numbers, whether you did it the long way or the short way. But my question was, how many entire pizzas can I buy? So I can't have a decimal as an answer, basically, is what we're saying, because I'm looking at entire pizzas. So the question is, do you round up or do you round down? If I round up to 5, that's going to cost me more than $80. So if I had like $82, I could have gotten 5 pizzas. But in this case, I only have $80 to spend, so we have to wipe out whatever the decimal is, and I'm only going to be able to buy 4 entire pizzas for the $80, and I'm just going to end up with change, hopefully for the tip for the person bringing the four pizzas. So this is where, if you had to do this problem, if you left it at a decimal, technically the answer would be wrong because the question is asking how many entire pizzas. You can't have 0.9 of a pizza unless the delivery guy ate a slice on his way, but hopefully he wouldn't do that. Or I guess 0.9 would be like a couple bites, not even a full slice. So that's how to turn word problems into ratios, and essentially it all comes down to turning them into dots and then turning them into fractions like we mentioned. But when you see these in word problems, again, if you can turn them into this if-then statement, that's how you know that you're going to be dealing with a ratio word problem. If you can't turn it into an if-then, then it's just going to be a general math or proportion type of word problem. So I hope this helped. I hope I taught you something new. See you later.